Similarity. Introduction. Students, you must have played with this toy in your childhood. If you open this doll, you will find another doll. Again opening, you will find another one, and so on. You will see that all these dolls look exactly similar with each other. The only difference is the size. In geometry, we use the term similar to indicate same shape and difference in size. If we go to a photographer with the same negative, he can give us two photographs of any size. Here, photo is exactly the same, but the sizes are different. So we can call them similar. In early standard, we have studied about congruent images, which means they have exactly same shape and size. We use congruent symbol to represent congruency. These two lines of the bottom shows the same size and this inverted S shows the same shape. Now look at these two pictures. These are similar. Here they are of same shape but not necessarily of same size. As same shape is indicated by this inverted S, we use this to represent similarity. Hence, these two images are same in shape and different size, hence called similar images. Now, we will try to apply this in geometry. Look at these figures, they are different similar figures. Look at these line segments, they are of same shape but sizes are different. Hence, are similar. Also, these squares are of different sizes but all are squares only. So, they are similar figures. Same with these circles. They all are area of same shape, that is, circular but of different sizes. Can we say triangles are also similar? Let us see these two triangles. When can I say that these are similar? If they have same shapes? They doesn't seem like similar in shape. Hence, these two are not similar. Now, look at these triangles. One small and other is large but with same shape. Now, put them like this. Triangle outside is larger than the triangle inside. Only difference is the size of the sides of triangle. If we take one more triangle with same shape but larger sides, you can put these triangles one inside the other. Here, outermost triangle looks like a projection of innermost triangle. If we call this as 1, this 2 and this 3, then 1 is similar to 2, 2 is similar to 3, and also 1 is similar to 3. That is, thus, if 1 is similar to 2 and 2 is similar to 3, then what we can say that 1 is similar to 3. Place lighted bulb at point O on the ceiling and directly below it a table. Place XYZ parallel to the ground between the lighted bulb and table. Then a shadow of XYZ is cast on the table. Mark the outline of this shadow as ABC. We get the larger ABC triangle of same shape on the screen. Then we see vertex X is corresponding to A, Y to B and Z to C. So then we can say triangle ABC is similar to triangle XYZ. To find their properties, we can measure the angle of these two triangles. They are A 60 degrees, B 60 degrees, C 60 degrees, X 60 degrees, Y 60 degrees, Z 60 degrees. That means corresponding angles of these two triangles are similar. Hence, angle A is equal to angle X. Angle B is equal to angle Y. Angle C is equal to angle Z. Now, we will measure the sides. They are 4 centimeters, 4 centimeters, 4 centimeters, and 2 centimeters, 2 centimeters, 2 centimeters. If you observe, you get 2 multiplied by 2 is equal to 4 in each side. That is, sides of one triangle are proportional to sides of another triangle. That is, AB is equal to 2 multiplied by XY, AC is equal to 2 multiplied by XZ, and BC is equal to 2 multiplied by YZ. Therefore, AB upon XY is equal to 2. AC upon XZ is equal to 2. BC upon YZ is equal to 2. Hence, the ratio of the corresponding sides of two triangles is same, that is 2. Hence, we can write AB upon XY is equal to AC upon XZ is equal to BC upon YZ. So, in two similar triangles, corresponding angles are the same and the ratio of corresponding sides is also same. All congruent triangles are similar, but converse is not true. Suppose some conditions are imposed on these two triangles. Condition 1. If the heights of both triangles are equal, then area of triangle ABC upon area of triangle PQR is equal to BC multiplied by H upon QR multiplied by H, which is equal to BC upon QR. Therefore, area of triangle ABC upon area of triangle PQR is equal to B1 upon B2. Property. The ratio of the areas of two triangles with equal heights is equal to the ratio of their corresponding bases. Condition 2. If the bases of both triangles are equal, then area of triangle ABC upon area of triangle APB is equal to AB multiplied by H1 upon AB multiplied by H2. Therefore, area of triangle ABC upon area of triangle APB is equal to H1 upon H2. Property. The ratio of the areas of two triangles with equal bases is equal to the ratio of their corresponding heights. Solved examples. Example 1. In adjoining figure, AE is perpendicular to segment BC. Segment DF is perpendicular to line BC. AE is equal to 4. DF is equal to 6. Then find area of triangle ABC upon area of triangle DBC. Solution. Area of triangle ABC upon area of triangle DBC is equal to AE upon DF. Bases are equal, hence areas proportional to heights, which is equal to 4 upon 6 is equal to 2 upon 3. Practice set 1.1. 1. Base of a triangle is 9 and height is 5. Base of another triangle is 10 and height is 6. Find the ratio of areas of these triangles. Solution. Let base of first triangle B1 is equal to 9. Height of first triangle H1 is equal to 5. Also, base of second triangle B2 is equal to 10. Height of second triangle H2 is equal to 6. Ratio of areas of these triangles is equal to B1 multiplied by H1 upon B2 multiplied by H2, which is equal to 9 multiplied by 5 upon 10 multiplied by 6. After cancellation, we get is equal to 3 upon 4. Therefore, ratio of areas of these triangles is equal to 3 upon 4. Let's learn basic proportionality theorem. Theorem. If a line parallel to a side of a triangle intersects the remaining sides in two distinct points, then the line divides the sides in the same proportion. Given, in triangle ABC, line L is parallel to line BC and line L intersects AB and AC in point P and Q, respectively. To prove AP upon PB is equal to AQ upon QC. Construction. Draw segment PC and segment BQ. Proof: triangle APQ and triangle PQB have equal heights. Therefore, area of triangle APQ upon area of triangle PQB is equal to AP upon PB. Equation 1. Areas proportionate to bases. And therefore, area of triangle APQ upon area of triangle PQC is equal to AQ upon QC. Equation 2. Areas proportionate to bases. Segment PQ is common base of triangle PQB and triangle PQC. Segment PQ is parallel to segment BC. Hence, triangle PQB and triangle PQC have equal heights. Area of triangle PQB is equal to area of triangle PQC. Equation 3. Area of triangle APQ upon area of triangle PQB is equal to area of triangle APQ upon area of triangle PQC from equation 1, 2 and 3. Therefore, AP upon PB is equal to AQ upon QC from equation 1 and equation 2. Practice set 1.2. 1. Given below are some triangles and lengths of line segments. Identify in which figures ray PM is the bisector of angle QPR. Solution. 1. Let us check the ratio PQ upon PR and QM upon MR. PQ upon PR is equal to 7 upon 3 and QM upon MR is equal to 3.5 upon 1.5, which is equal to 7 upon 3. Therefore, PQ upon PR is equal to QM upon MR. Therefore, using angle bisector theorem, ray PM is the bisector of angle QPR. 2. Check the ratios is equal to PR upon PQ and RM upon MQ. PR upon PQ is equal to 7 upon 10 and RM upon MQ is equal to 6 upon 8. As PR upon PQ is not equal to RM upon MQ. Hence, by angle bisector theorem, ray PM is not the bisector of angle QPR. 3. Let's check the ratios PR upon PQ and RM upon MQ. PR upon PQ is equal to 10 upon 9, which is equal to 1.11, and RM upon MQ is equal to 4 upon 3.6, which is equal to 1.11. Therefore, PR upon PQ is equal to RM upon MQ. Hence, using angle bisector theorem, ray PM is the bisector of angle QPR. Let's recall. Similar triangles. In triangle ABC and triangle DEF, if angle A is congruent to angle D, angle B is congruent to angle E, angle C is congruent to angle F, and AB upon DE is equal to BC upon EF is equal to AC upon DF, then triangle ABC and triangle DEF are similar triangles. Triangle ABC and triangle DEF are similar is expressed as triangle ABC similar to triangle DEF. For more information, proof of AAA test given in triangle ABC and triangle PQR, angle A is congruent to angle P, angle B is congruent to angle Q, angle C is congruent to angle R. To prove triangle ABC is similar to triangle PQR, let us assume that triangle ABC is bigger than triangle PQR. Mark point M on AB and point N on AC such that AM is equal to PQ and AN is equal to PR. Show that triangle AMN is congruent to triangle PQR. Hence, show that MN is parallel to BC. Now, using basic proportionality theorem, AM upon MB is equal to AN upon NC. That is, MB upon AM is equal to NC upon AN by invertendo. MB plus AM upon AM is equal to NC plus AN upon AN by componendo. Therefore, AB upon AM is equal to AC upon AN. Therefore, AB upon PQ is equal to AC upon PR. Similarly, it can be shown that AB upon PQ is equal to BC upon QR. AB upon PQ is equal to BC upon QR is equal to AC upon PR. Therefore, triangle ABC is similar to triangle PQR. AA test for similarity of triangles. We know that for a given correspondence of vertices, when two angles of a triangle are congruent to two corresponding angles of another triangle, then remaining angle of first triangle is congruent to the remaining angle of the second triangle. This means when two angles of one triangle are congruent to two corresponding angles of another triangle, then this condition is sufficient for similarity of two triangles. This condition is called AA test of similarity. Solved example. Example 1. In triangle XYZ, angle Y is equal to 100 degrees, angle Z is equal to 30 degrees. In triangle LMN, angle M is equal to 100 degrees, angle N is equal to 30 degrees. Are triangle XYZ and triangle LMN similar? If yes, by which test? Solution. In triangle XYZ and triangle LMN, angle Y is equal to 100 degrees, angle M is equal to 100 degrees. Therefore, angle Y is congruent to angle M. Angle Z is equal to 30 degrees, angle N is equal to 30 degrees. Therefore, angle Z is congruent to angle N. Therefore, triangle XYZ is similar to triangle LMN by AA test. Solved examples. Example 1. Triangle ABC is similar to triangle PQR. Area of triangle ABC is equal to 16. Area of triangle PQR is equal to 25. Then find the value of ratio AB upon PQ. Solution. Triangle ABC is similar to triangle PQR. Therefore, area of triangle ABC upon area of triangle PQR is equal to AB square upon PQ square. Theorem of areas of similar triangles. Therefore, 16 upon 25 is equal to AB square upon PQ square. Therefore, AB upon PQ is equal to 4 upon 5. Taking square roots.
अगर आप अपने सिलेबस के सारे चैप्टर्स इस फॉर्मेट में देखना चाहते हैं तो हमें डिस्क्रिप्शन में दिए गए नंबर पर कॉल करें। ऐसे ही और एजुकेशनल वीडियोस देखने के लिए हमारे चैनल होम रिवाइज को सब्सक्राइब करें।